faithfully delivering value by interpreting great books from around the world. Hello, I'm Sally, your book narrator here. Today, I'll be interpreting the book Weather Forecast for you. Its subtitle is A History of Scientific Exploration. It's a topic we all care about in our daily lives. Besides what to eat, we're often wondering about today's weather. But actually, we haven't had weather forecasts for long. They only started in the 1860s. Back when there were no forecasts, travel was risky and inconvenient. Fishermen had a dangerous job. A storm at sea could mean no return. Outdoor events like horse races relied on luck. A sudden thunderstorm would ruin everything. Weather forecasts saved us from many losses due to extreme weather. How did early people interpret the skies? And how did the forecast system evolve? This book tells the story of how weather forecasts were born in the 19th century. And the author, Peter Moore, is a British science writer and teaches creative writing at Oxford University. Moore researched extensively, consulting meteorology professors for this book. It combines rigorous research with a human touch and was named a top book by the New York Times and The Times. The head of the UK Met Office praised it as insightful. The book features navigators, painters, astronomers, engineers, and more. Some soared in balloons high up, others sailed the seas, all facing storms with simple tools, observing and testing to build meteorology and give us weather prediction. Next, I'll guide you through the birth and growth of weather forecasting. The book has 3 parts. Part 1. How did people record weather in meteorology's early days? Part 2. How did we gather weather data as technology advanced? Part 3. How was the early forecast system built? Weather study began with observation. How did we record what we saw? In Part 1, we'll cover recording wind speed, classifying clouds, and drawing weather scenes in meteorology's early days. Before the 19th century, weather was a mysterious thing. The Navy couldn't measure wind speed, balloon pilots couldn't explain the sky's color, and painters couldn't find the right words to describe the clouds in their art. For most people, weather was like background music played by God, hinting at changes or punishing sins. Humans were small and helpless before nature. When storms hit, all people could do was pray. Meteorology was a blank slate. Not even a standard set of terms to describe weather changes existed. Standardized weather recording began with wind. In the 18th century, people could only use flowery language to describe wind's traits, like a strong wind blowing from Southampton, a sudden gale from the harbor. Shakespearean storm descriptions, each wind tested people's imagination. Sailors at sea were most focused on wind, but due to varying ship resilience across nations, they couldn't agree on descriptions. For instance, a storm that wrecked Japanese ships. To British sailors, it was just a cool, strong breeze. A British naval officer, Francis Beaufort, realized that recording wind with subjective judgment wasn't practical. In 1791, Beaufort served on a Royal Navy ship. From then on, he developed a habit of recording weather. By 1805, his weather logs got more detailed, sometimes assessing wind speed, light breeze, gentle breeze, strong wind, soft wind, and so on.
By 1866, Beaufort tackled the challenge of quantifying wind force.
Innovative, systematic, writer, budding, he set 13 levels for wind force, from level 0 calm, level 1 light air, to level 12 hurricane, level 13 violent storm. After that, Beaufort created a code with 29 symbols to describe different weather types. Some codes were single letters, others 2-letter combos, like B for clear sky, SQ for squally, R for rain, etc. Beaufort also made a flexible, simple weather log form that recorded wind direction, speed, and tracked complex weather changes. For example, writing January 13th, 1806, BSQ 4 to 10 meant clear and windy weather, wind force between a light breeze and strong gale. Beaufort's log solved an age-old problem and started modern meteorology. Just like describing wind, in the 18th century, People described clouds using literary language. Most saw clouds as near decorations in the sky. An imaginative weather recorder could depict clouds as hundreds of everyday items like combs, spiderwebs, palm leaves, and foxtails. Of course, this poetic recording method, detached from science, also met its end. In 1802, British chemist Luke Howard proposed a system for classifying different types of clouds. Howard spent several years observing the sky. He divided the varying clouds into three main categories. The first is cirrus, usually high in the sky, with curled edges spreading out like feathers. The second is cumulus, with distinct outlines, piling up layer by layer. The third is stratus, thin and continuous, spreading out at low altitudes. Additionally, there are mixed forms: cirrocumulus, cirrostratus, stratocumulus, and cumulonimbus, making 7 types in total. This classification method for clouds has lasted to this day and is recognized as a major contribution to 19th century meteorology. Oh, in the early 19th century, painters also made significant contributions to weather recording, including a British landscape painter named John Constable. Constable once worked as a miller. Operating windmills required constant attention to weather changes. If millers couldn't retract the blades before a storm, the high-speed rotation could cause the windmill to catch fire. I like that. All you have to do. So Constable was also an experienced weather observer. For instance, he observed wind shear phenomena. Wind shear refers to winds at different altitudes blowing in opposite directions, meaning the wind blows vertically. Constable depicted wind shear by showing clouds being split in two by the wind. From 1820 to 1822, Constable created over 100 sketches recording the sky from different angles, at different times, and under various weather conditions, while adding notes on location, time, and weather on the artworks, preserving natural records through painting. From Beaufort to Constable, they achieved faithful weather recording through their own methods, establishing meteorological classification systems. This marked the awakening of atmospheric science research in the early 19th century. When time reached the 1820s, with the spread of measuring tools, humans began studying weather phenomena in unprecedented ways. They collected weather data at home, at sea, on mountaintops, and in hot air balloons. Next, let's move to the second part: human collection of meteorological data. With technological advances, instruments like thermometers, hygrometers, and barometers became widely used. They turned felt weather, like foggy mornings or post-storm afternoons, into quantified data: humidity, temperature, etc. On ships to New York, sailors checked their route by measuring sea temperature. If the route's temperature was higher than surrounding waters, they were sailing against the current. On the North Atlantic Current, the ocean's great river, hygrometers measured moisture to predict fog, dew, and rain. For example, when night temperatures drop sharply, increased moisture leads to dew formation. Barometer, it could also predict weather. Sudden pressure drops often signal wind and rain. Conversely, high stable pressure indicates clear weather. Meteorologists used precise instruments to record weather, valuing quantified facts and experimental knowledge. Another key invention advanced meteorology: the telegraph. In 1844, American Samuel Morse sent history's first telegram to Baltimore. Telegraphs enabled instant communication between distant weather stations, allowing rapid, large-scale data collection. Why collect large-scale weather data? Because weather changes develop dynamically across space. For example, coastal residents track typhoons via real-time systems. A western Pacific storm can hit shore within 24 hours. So, large-scale weather knowledge is crucial for building forecasting systems. In the 1850s, meteorologists created growing networks to share data via telegraph, making weather forecasting possible. But for accurate forecasts, ground-level data isn't enough. We need upper atmosphere insights too, since its pressure, temperature, humidity, and cloud edge winds crucially impact surface weather. And today we have weather satellites to gather upper atmosphere data. So, how did people explore the upper atmosphere over a century ago?
They came up with an idea. Send scientists in hot air balloons with equipment to record high altitude data, expanding atmospheric observation.
At the 1862 British Association meeting, the Balloon Committee was formed. They recruited meticulous British astronomer James Glaisher, who'd studied dew and snow crystals and was passionate about this work. He joined veteran balloonist Henry Coxwell aboard the Mammoth, the era's largest balloon, to explore the skies.
After 2 successful flights, they decided to go higher.
Thus began a nationally sensational scientific expedition. It was an afternoon in September 1862. As the balloon climbed, Glaisher repeatedly recorded barometer, thermometer, and hygrometer readings. Temperatures dropped rapidly during ascent. At 20,000 feet, about 6,100 meters, equipment began failing. But they chose to climb higher. At stratosphere's edge, Mount Everest's height, thin oxygen made Glaisher lose consciousness.
Revived, Glaisher resumed observations like it was minor trouble. Coxwell used his last strength to release ropes for landing.
This flight redefined human boundaries, revealing atmospheric layers. Glaisher's data showed the upper atmosphere's complexity. Contrary to expectations, air temperature doesn't steadily drop with height. It alternates between colder and warmer zones. That concludes part 2. Data collection and analysis form forecasting's foundation. As instruments advanced, meteorological studies appeared in journals, with weather societies and networks emerging. So how do we put this observational data to use and genuinely serve people's daily lives? Next, let's dive into part 3, how the early weather forecast system was set up and what pressures it faced. The predecessor of weather forecasting was the storm warning system. Back in 1860, Dutch meteorologist Christoph Buys-Ballard started providing storm warnings for sailors in his country. He set up 4 weather stations along the Dutch coastline and developed a method using pressure deviations to determine wind direction. And pressure deviation means the difference between a location's air pressure and its average pressure over past years. If a southern station's pressure deviation is higher than a northern one's, strong winds will blow from the west. Conversely, winds come from the east. To this day, this law is still remembered by many sailors. Simply put, in the northern hemisphere, if pressure is low on your left, wind will blow from behind you. In France, astronomer Urbain Le Verrier was also running a similar service. He equipped the observatory with top instruments to record daily weather like temperature, wind force, and pressure. He also built a telegraph network to send data from provinces to the observatory, enabling real-time tracking of storm direction and wind speed changes. Warnings were issued before hurricanes made landfall. However, across the Channel in Britain, a meteorologist named Robert Fitzroy had an even grander plan. You might not know Fitzroy, but you've probably heard of the HMS Beagle, which Darwin sailed on during his voyage. Fitzroy was the captain of the HMS Beagle.
Fitzroy was born into a traditional conservative family. His father was a general, and his grandfather had been British Prime Minister.
Fitzroy was fascinated by the sea from a young age. He was a star in the British Royal Navy and got a solid education. In 1853, the British government set up a special department to collect and observe maritime weather data, chart navigation maps, aiming to cut sailing costs. Fitzroy had commanded the Beagle, landed on Horn Island, and mapped the Strait of Magellan. With rich practical experience and deep scientific knowledge, he was clearly the best pick to head the meteorological department. Fitzroy truly brought the same drive he had on the Beagle to this new role. He excelled in meteorological research, built his own ship network, and published wind star charts. So-called wind star charts divide the ocean into many squares, each marked with different star patterns representing wind force and direction in that area, making wind data along routes clear at a glance. Additionally, he designed a new barometer that replaces the common numerical scales with descriptive words, making it easier for users to read. Fitzroy wasn't satisfied with just recording data and drawing charts. He wanted to study weather scientifically, provide early warnings for severe weather, giving coastal residents and sailors at sea a chance to avoid storm attacks. Fitzroy decided to use the meteorological data collected by the Weather Bureau over the years to establish a storm warning system.
The theoretical basis for this warning system is the collision theory of cold and warm air fronts.
Meteorologists found that when cold and warm air masses meet in the sky, they collide, causing atmospheric vortices, which are the source of all storms. The collision of air masses can be judged by the rate of temperature or pressure change in an area. The faster the change, the more intense the collision, and the greater the chance of a storm. All of those things were axiom. Fitzroy's Weather Bureau analyzed meteorological data from the telegraph network, calculating rates of pressure and temperature changes to predict storm formation. Fitzroy also designed a signal system on the coast to convey weather information to ships at sea. For example, a cone pointing upward means strong winds coming from the north. A single drum indicates wind blowing continuously from the opposite direction. These cones, or drums, are hung on docks, visible to ships kilometers away, helping them decide whether to sail on or return to port. In February 1861, Fitzroy issued the first storm warning. He observed a storm over the Atlantic that would hit the British coast, and his prediction was correct. This success gave Fitzroy a great start. From then on, the Weather Bureau's work changed. Previously, its main focus was analyzing historical records and log data. Now, it required careful and accurate analysis of real-time meteorological data from the telegraph network to issue storm warnings. This transformation was significant, making the volume and transmission speed of meteorological data very important.
In August 1861, Fitzroy decided to expand his storm warning system from the initial 50 application points to 130.
Meanwhile, he didn't want to waste the daily weather data analysis, so he decided to send it to newspapers.
As a prediction for the next day's weather, on August 1st, 1861, the Times published an unassuming notice stating the weather forecast for the next 2 days. Light westerly winds and clear skies in the northern region, light southerly winds and clear skies in the western region, and stronger westerly winds and clear skies in the southern region. This notice marked the birth of the world's first official weather forecast. Storm warnings were initially to protect sailors, but Fitzroy's public forecasts opened the door to meteorology for the masses.
6 newspapers continuously published Fitzroy's weather forecasts, which were hugely popular with readers.
From businessmen planning trips to tourists heading to the beach, everyone eagerly followed the weather forecasts in the papers. If it's a sunny day, you can go out satisfied without an umbrella. Even the Queen's messengers would visit just to ask Fitzroy about tomorrow's weather for the Queen's boating trip preparations. And Fitzroy's weather research work finally gained recognition. The Weather Bureau's budget also increased, and it became a department with a noble mission. Fitzroy hired more and more employees, but was the weather forecasting business smooth sailing from then on? Fitzroy soon faced immense pressure, the first source being religion. At that time, most Europeans believed weather was controlled by God, and many towns had traditions of storing weapons on church towers. People thought God wouldn't allow fires in such places, but church lightning strikes happened often, like in Italy, where a tower storing over 900 tons of gunpowder was struck, killing more than 3,000 people. Christians couldn't explain why God always attacked church spires that glorified him, instead of lowly taverns or dens of sin. It wasn't until Benjamin Franklin's kite experiment and the lightning rod invention that people understood why tall objects attract lightning and found ways to prevent it. And as late as 1960, British bishops would still order priests to pray for dry, clear weather during harvest season. Fitzroy himself was a devout Christian, holding an extremely rigid and conservative view of the Bible, even falling out with Darwin over his rejection of evolution. However, meteorological work requires innovation, exploration, and experimentation, plunging him into deep self-contradiction. Day after day, he processed data, flooding his office, then attended church every Sunday, praying for favorable weather. The primary pressure Fitzroy faced came from his own inner conflict. The second pressure was that weather forecasts were sometimes unreliable. Even today, with satellite monitoring and supercomputers, sudden weather changes remain unpredictable. How much harder over a century ago, with only basic equipment and manual data processing? When Fitzroy's forecasts proved accurate, people hailed him as a trustworthy scientist.
Weather forecasts.
When mistakes happened, people dismissed Fitzroy as a charlatan. Roy's reputation depended entirely on daily weather and critics' moods.
Fitzroy cared deeply about these judgments, working harder to prove himself.
Fitzroy admitted errors occurred, emphasizing interpretation's importance, but people only wanted certainty. Yet Fitzroy couldn't provide certainty, driving him toward mental collapse. The third pressure was Fitzroy's reliance on experiential judgment without theoretical backing. The winter of 1862 to 63 was brutal for the Weather Bureau. Storm warnings lost novelty, scrutiny intensified, and meteorologists grew troubled by Fitzroy's unsystematic, inexplicable methods. What principles guided forecast formation? The nation had meteorologists with competing theories: lunar influence advocates, anticyclone theorists, astrometeorologists, and cyclone believers. No theory had reliable verification. No one could convince others, leaving people free to choose preferred views. Fitzroy drifted between them, agreeing with many ideas but remaining vague about his own methodology. Finding no systematic theory, Fitzroy focused solely on practical forecast operations. During these years, the meteorology department's funding kept increasing. While Fitzroy believed storm warnings saved lives, justifying national investment, many grew increasingly dissatisfied. In 1854, the initial mission of the Meteorological Office was to chart wind patterns, helping British merchant ships accelerated across oceans to generate national profits. Now, wind charting progress stalled while storm warnings multiplied. Parliament members questioned and criticized Fitzroy, calling his meteorology playing God. These accusations left Fitzroy bewildered. Publications like The Times mocked his project, claiming nature's ancient signs, moon halos, donkey brays, duck calls, were better forecasts. Fitzroy's early optimism vanished. In autumn 1864, the Board of Trade slashed his budget. Already data-starved, Fitzroy issued forecasts with even scarcer information, exhausted by criticism. The once vigorous captain grew frail, gaunt, hollow-eyed, completely bald. In 1865, overwhelmed by pressure, Fitzroy calmly chose suicide, ending his life's work tragically. Posthumously, Fitzroy's contributions were reevaluated. Britain's forecasting system restarted after 13 years. For Fitzroy, who witnessed sailors swept into seas, weather research wasn't just data, it was a driving force. He thought to predict weather not just for sailors, but for everyone impacted by storms. This concludes the book's core content. Meteorology's pioneers included Beaufort and Howard, who standardized records, and Gleicher, who ballooned to 30,000 feet. Fitzroy treated forecasting as a mission. They found order in chaos, truth in fog, helped sailors battle storms, yet were too ahead of their time. As poet Emily Dickinson said, "Truth's light must dawn gradually, or else blind us all." New sciences always rise on rocky paths. Time reveals true answers. All right, that concludes our interpretation of weather forecast. Reading notes are below the audio. See you next time.